This week, the homework will be to write several functions over linked lists. The file is going to be called mylinked1, and you'll find it in the hw3 folder. I just want to make sure first you understand what the problems are meant to do. The first problem is to produce a size function. And if you have a list with 2 elements, the result should be 2. If you have a list with 4 elements, the result should be 4. So it's computing the size or the length of the list. And I'm going to have you do this 3 times. So the first time, you're going to write it using a while loop. The second time, I want you to write that using a forward recursion. So that's computing in the same style as the while loop, computing the result going forward, and then at the very end, just returning that result all the way back. And third, I want you to write a backwards recursion. So that's where we just go all the way to the end of the list by doing recursive calls, and then we do the computation or the addition going back in the back end. So that's 3 versions of the size function. Then I'm going to have you write 2 slightly more complex functions. The first is just to find the position of the first 5 from the beginning of a list. So here, if I have this list, the 5 is at index 0, the first 5. Here, the first 5 is at index 2. Here, the first 5 is at index 3, and here at index 4. Here, it's at index 0. Here, there's a lot of 5s, and the first one is at index 3. The next function is called position of last 5 from the end. And it's sort of similar, except that in this case, we're going to find the last 5 from the end. So here, this 5 is 3 from the end. So 0, 1, 2, 3. This is at position 2 from the end, 0, 1, 2. Position 1, position 0, position 4. And if I have a whole bunch of 5s, well, this guy is at position 2, so 0, 1, 2 from the end of the list. If something is not found, if we don't find a 5, then you just return a negative number. And in my test here for position of first 5 from the beginning, it's returning -1. Just return -1 if there's no 5. And likewise, in position of last 5 from end, you can return any negative number. But my tests here are for a certain kind of algorithm. So you can write these algorithms using loops, or you can write them recursively. And it's an interesting exercise to try and write these as forward recursion and as a backward recursion. So if I'm computing the answer here going forward, it's relatively straightforward how to compute that in a recursive function, because it's just like I would in a loop. When I hit the first 5, I return the position I've gotten to at that point. And if I get to the end of the list, my base case would simply be a negative number. Fine, that's easy enough. I encourage you to try implementing position of last 5 from the end using a backward recursion. But if you do this, it actually is a little bit tricky. You have to think a bit before you start. And the negative numbers I've chosen here in the tests reflect a particular way of doing this. So I want to show you the idea of this approach. I'll do it showing you some more examples. The idea here is that if we don't find a 5, we return a negative number, and we can return any negative number. So we can choose to encode some information in that negative number. In particular, I can choose to encode the position from the end of the list. So here, if I have an empty list and I invoke position of last 5 from the end, the way I've written it, it'll return -1. If I have 1 element, it'll return -2, 2 elements, -3, etc. So here, if I have 4 elements and I invoke position of last 5 from the end, I'll get -5. Now, if I'm doing a backward recursion on this list, I will first invoke the position of last 5 from end on this sublist, starting with 11. And so I'll get back the result, if I wrote it this way, I'll get back the result -5. At this point, I see a 5. So seeing a 5, I need to do something. So when I see a 5, I can say, oh, how far am I from the end? Well, this isn't telling you. You can just take this number, add 1, and then invert, and you'll get 4. Now, once I've got a positive number as a result, so if you think about doing a backwards recursion on this particular list, I've got a 5 here, but the result that I get from the recursive call is already going to be a positive number. So I'm not going to want to do anything. I just say, well, there's a 5 toward the end, so I'll just pass it back. So that's the idea of one way of encoding the backwards recursion for position of last 5 from the end. The idea here is I'm simply using this, the space of integers. So half of it represents positive results and half of it represents negative results. And you can just play around in there. The last problem I'm going to ask you to do is to simply delete the first element from a list. And this is not too hard, but you have to think about it just a titch. And this is a warm-up for next week's homework, where we will be looking at mutators over linked lists.